I'm Anil Kumar. In this video, we will learn the concepts to find probability of mutually exclusive events. Now, before getting in there, let us understand what are mutually exclusive events. I like to start from the very beginning. Let us say we have a sample space here, right? So this is the sample space where we have two events. Let's say event A and event B, and they are kind of not connected or not overlapping. We call them disjoint, right? So let's say these two events are such that there is nothing common between them. We also call them as disjoint sets, right? So they are not connected. So in our sample space S, we're talking about two events A and B which do not have any common elements. So no common elements, right? So no common elements. So that becomes a disjoint set. So when we are trying to find probability of such events where there is nothing common, for example, we are talking about throwing a dice and getting even number and tossing a coin and getting heads. Now in this event, nothing is common. So these probabilities, they just add up, right? So when we have option of two events where there is nothing common, and in which case we find that the union of the two events is actually equals to number of elements in A plus number of elements in B, right? Kind of. So if you count the number of elements, we can just add them up, right? So such events are called mutually exclusive events. Okay, so these are called mutually exclusive events. We'll take up such events in our example. One I gave you, throwing a dice and tossing a coin. There's nothing common in the results, correct? So you can add both if we are doing OR operations, right? This or that, correct? So for OR operation, we can always combine the events. Well, here itself, let me talk about the other events which are non-mutually exclusive. So let me take another example here where we may have events which kind of overlap. For example, let's say here is event A and then we have event B. You can clearly see that in this sample space we're talking about two events A and B, and this area here is common. So that means the union of these two events A union B is not equal to the sum of A and B, right? Can you tell me why? It is mainly because they have some common elements. In this case, the union will be elements of A plus elements of B. Take away the elements which are common because we are counting them twice. So which is intersection of A and B, right? So that makes the huge difference. And these events which we're talking about, let me just draw a line here. These events, let's say this is case A, right? Case A, and this is case B, right? So that case, these are non-mutually exclusive. Non-mutually exclusive. So these are different, right? So in mutually exclusive, we have disjoint functions, so we can combine the numbers. In non-mutually exclusive, we include few twice, so we have to exclude them. So we'll talk about it later when we talk about inclusion and exclusion, right? Now let me take some more examples with which we can find probability. So let's take an example playing with the dice, right? Let's say we have a dice here. We got a number 1. So as you know, 1 is a perfect square, right? So let us say that we defined event A, which is a set of perfect squares. Perfect squares, right? So set of perfect squares. So when we are talking about a dice, which you've taken here, what is the sample space? The sample space in this case is numbers 1 to 6. Is that okay? Yes, that is, right? So numbers 1, 2, 3, 4, 5, and 6 are in our sample space. Now, out of these numbers, which ones are perfect squares? Well, we have 1 as a perfect square, that is 1 square. Then 2 square is 4. So we got 2 perfect squares. So we can say the number of elements which are perfect square are actually 2 for us. Good. Now let's take another event. We'll call that as event B, and let that event B set off, let's say, prime numbers. Okay. Prime numbers. Now, when we say prime numbers, in that case, what will be the set? So out of these numbers, the prime numbers are 2, 3, and 5. Can you tell me why 1 is not included? 1 has only one factor, not 2. 2, 3, and 5 all have 2 factors, 1 and the number itself. So those are the prime numbers. And so the number of elements which we have in the event B, let me say n of B, is actually 3. Do you see that? Now the question is, find the probability of A or B, right? A or B, which we also write as probability of A or is union, right? A union B, either way. Now in that case, we can say that total number of elements are how many? Okay, let's get back to this sample space and then we'll move forward. So what we have here is, in our sample space, we have defined 2 events, A and B. I've drawn them separately since I do not see any common numbers between these, right? So this is event A, this is event B. Let me write down their elements. In A we have 1 and 4, and in B we have 2, 3, and 5. Correct? So where is 6? 6 is outside. You see, 6 is not in event A or in event B. So the probability of A union B is, we can count these numbers. These are favorable numbers, which is actually the sum of number of elements in A plus number of elements in B divided by total number of elements in our sample space. Correct? So what you see here is that the probability is a real combination of 2, right? You could write this also as n of A divided by n of sample space plus probability of A divided by probability of B, right? So you can simply combine these two, you understand, and get your answer. So it is, as you can see, you could write 2 plus 3 over 6, or let me now write as I combine them like this. In any case, it is 5 over 6. 5 are the elements which are in A or B, and in our sample space we have 6 elements. You get an idea, right? So that is the case when we are talking about mutually exclusive events. Their probabilities add up. So what we learned here is that for mutually exclusive events, so probability of A or probability of B is kind of probability of A plus probability of B, right? You can also write this as probability of A or like this. Do you understand? This is what we're trying to say. That is for mutually exclusive events. Now let me take up an example just to show you the difference where the events may not be mutually exclusive. For example, if we take an event C, we already have defined A and B as even numbers. Even numbers, right? So in that case, what do we get? So in this case, in the dice, 2, 4, and 6 are even numbers, right? 2, 4, and 6 are even numbers. Now, can you tell me what is the probability of, let us say, A or means union C? Now, A or C, if you consider, in that case, if you combine 1, 2, 3, 4, and 5, you think there are 5 favorable numbers. You will do a mistake since 4 is common. Do you see that? this is not mutually exclusive. Let me write down, not mutually exclusive. You know why? Let me just get back to this example. Then this is a small space. We'll consider this example once again. But let me give you in short what is happening here. So in our sample space, we have something common. So let's say this is the sample space. This is event A, this is event B. We have something common here. In event A, we have 1 and 4. Events, I should have written C. Okay, let me correct this C. Okay, C. So we are talking about even numbers and perfect squares. So even numbers are 2, 4, and 6. 4 is common. Do you see that? And so we get 2 and 6 here and number 1 here. So the probability of A union C is not, you just can't add them. So in this case, the probability is, let me rewrite A union C is equals to n of A plus n of C, take away intersection n of A intersection C and divide by n of S. Do you understand? So in this case, the probability is really 2 plus 3 minus 1, because 1 is common, right? Divided by 6. It is not 5 over 6 in this case. It is 4 over 6, right? 5 minus 1, 4 over 6, 4 over 6 or 2 over 3. So that is the case when the events are non-mutually exclusive. So what you learn here is mutually exclusive, nothing common, disjoint functions, and so you can just add up the probabilities. But if the event is not mutually exclusive, then you have to take away the ones which are included twice, right? So we'll talk about the principle of inclusion and exclusion. So you include it when you do A plus B twice, and so you have to exclude it. That's the whole idea. I hope with this the concept is very clear. We'll take a few more examples to elaborate. I'm Anil Kumar, and I hope that helps. You can always share and subscribe my videos. Thank you and all the best.